that we just stay here, 'cause in this kind of weather, what could it be better? Just come right on over, make yourself comfy.
Hi, I'm Analytic.
Your on me ain't perfect, but I wouldn't change a thing.
Assalamualaikum and good morning. Today, my friends and I will be presenting our project under topic Analytical Geometry, TST0115 Mathematics Science.
This is our group member.
We built a bridge named Parabola Bridge IMI. IMI stands for the initials for each for our names.
Looking forward to the type of analytical geometry that is related to the parabola. So first of all is the conic section. Parabolas are part of the conic section, which also includes ellipse and hyperbolas. Conic sections are curve formed by the intersection of a plane with a double nape cone, and each type of the curve has a specific properties. Moving to number 2, quadratic functions. In the context of quadratic functions, parabola are represented by equation like where the shape and direction of the curve depend on the values of A and B and C. Next, focus and directrix. One of the most defining characteristic of a parabola is its relationships to its focus and directrix. Every point on the curve is equidistant from both a property that is central in both geometry and practical application like satellite dishes. And this one is some of the similar example with our project that use the parabolic concept. For example, parabolic microphone, satellite dishes, and solar cookers.
This is the material used while making this parabolic bridge, which is glue, scissors, and cardboard. Why the bridge is suitable with parabolic structure? First, it is even weight distribution. In a parabolic arc bridge, the weight of the bridge and any additional load, like cars, is distributed evenly across the arc. Each part of the arc helps support the load by directing the force downward along the curve, which reduces the stress on individual points and spreads it throughout the structures. This is especially useful in supporting long spans. Second, aesthetic and functional design. Parabolic arches also add to the bridge's visual appeal while serving a functional purpose. The shape creates a balanced, symmetrical look that's pleasing to the eye and is a hallmark of iconic bridge around the world. The last one is minimal material for maximum strength. The parabolic shape allows engineers to achieve a high level of strength with relatively minimal materials, which makes it both cost-effective and structurally efficient. Parabolic arches are self-supporting, so they don't require as many additional supports as flat or straight structure might.
Now, we want to prove that the line y equals to ms plus c is a tangent to the ellipse b square x square plus ss square y square equals to s square b square if s square m square equals to c square minus b square. So, this is our first equation and this is our second equation. So, we need to substitute this y into this y. So, when we substitute, we solve this equation like usually, expand it and solve it until we get the final is quadratic equation. So when we look back into the question, it says y equals to ms plus c is tangent to the ellipse. So y equals to ms plus c is a straight line, and b square s square plus s square y square equals to s square b square is a ellipse equation. So when y equals to ms plus c cross with ellipse, it will have 1 point. So we need to use the discriminant formula, b square minus 4ac equals to 0. So from the quadratic equation, so we know a is a b square plus a square m square, b is a 2s square mc, and c is s square c square minus s square b square. So we substitute into the discriminant formula. So this is b, a, and c. So we expand like usually and solve it until the end, and we have proof that s square m square is equal to c square minus b square. So this is true because line y equals to ms plus c is a tangent to the ellipse b square s square plus s square y square equals to s square b square. So that's all from us. Thank you.
That's all from us. Thank you.